Unit 2 review. So today we're going to work on Unit 2 review. It's a we do, I do review. So I'm going to go over and explain how to do the we do side, and then on your own you're going to try to do the I do side. Remember, when you're working on the I do side, if you get stuck, just look at the corresponding we do question on the left. Okay, let's look at number 1. Number 1 says state whether the relation represents a function or not, and then explain. So remember, a function is when the x values do not repeat. So let's look at this map and let's turn them into points so it's easy to see what the x and y values are. So first we have -6, which has an arrow pointing to -8. So that point is going to be -6, -8. Okay, then we have 1 pointing to -8. So that's going to be 1, -8. Then we have 2 pointing to -5. So that's going to be 2, -5. And 3 pointing to 7. So that's going to be 3, 7. So now we're looking if any of our x values repeat. So we have -6, 1, 2, and 3. None of them repeat, so this is a function. So let's say it also asks for the domain and range. Remember, domain is the x values. So the domain in this case is going to be all the x numbers. So we have -6, 1, 2, and 3. And then the range is going to be all the y values. But remember, we do not need to repeat a number twice. So we have -8, -5, and 7 as the range, which is the y values. Okay, let's look at number 2. Number 2 says state whether the relation represents a function or not. So remember, when we have a graph, we're going to use the vertical line test. So vertical line test. And remember, we are checking to see if our vertical line hits the graph more than one time. If it hits the graph more than one time, it is not a function. So let's check our graph and draw a vertical line. Notice that my graph crosses here at the bottom and right here at the top. So since it crosses it at 2 points, this is not a function. Not a function because the graph crosses our vertical line twice. So not a function. Okay. So let's look at number 3. Number 3 says state whether the relation represents a function or not. So just like on number 1, we have our points listed and we're checking if the x values repeat. So let's circle all of our x values. Okay, these are all of our x values. Now we're seeing if any of them are the same. So we have a -8 and a +8, so those are different. We have a -3 and a +3, those are different. And then we have a +6. So since they are all different x values, this is a function. So function because all the are different. Okay. Number 4. Number 4 says given the equation g of x equals 3x squared plus 1, find the following values. So remember, if we see a letter with an x in parentheses, that is the same as y. So this is the same as saying y equals 3x squared plus 1. And it wants us to find g of negative 2. So if it's inside the parentheses, this negative 2 is my x value. So I need to plug in negative 2 for x. So I have y equals 3 parentheses negative 2 squared plus 1. So instead of my x value, instead of this x value, I put a negative 2. Okay, and then I solve. So negative 2 squared is the same as saying negative 2 times negative 2, which is 4. So I have y equals 3 times 4 plus 1. And then 3 times 4 is 12, and 12 plus 1 is 13. So my answer is 13. And if I was to write this as a coordinate point, this is my y value. And remember that negative 2 was my x value. So the point is going to be negative 2, 13. So that's my answer. Okay, and we're going to do the same thing, but with 3. So remember, it's inside the parentheses, so this is my x value. So I have y is equal to 3 parentheses 3 squared plus 1. So remember, this x over here is now a 3. So if I was to simplify this, 3 squared is the same as 3 times 3, which is 9. So I have 3 times 9 plus 1. 3 times 9 is 27, and 27 plus 1 is 28. Remember, this is my y value. So the point is going to be 3, 28, and that's my answer. Okay, number 5. Number 5 says use the given graph to find the following values. So right here, it wants us to find f of 3. Remember, if the 3 or any number is inside the parentheses, this is an x value. So it gave us x, and we need to find y. So I'm going to go find 3 on the x's, which is right here. And then I'm going to try to see what point that is on the graph. So if I bring this down until it crosses the graph, and I look over at the y values, that y value is negative 4. So my answer is negative 4. And if I was to write that as a point, if we look at the graph, this point right here, which is our answer, is going to be 3, negative 4. Okay. Next, it says find x when y is 4. So when y is 4 this time. So I'm going to find 4 on the y's, so right here. And I'm going to see where that value is on the x's. So right here. So if we follow the 4 to touch the graph, we notice that that x value is negative 1. So x is equal to negative 1. And if we find that point here on the graph, that point is negative 1, 4. That's our answer. Okay. One last time, it says find x when y is negative 2. So when y is negative 2, that's right here. Okay. I'm going to see where that connects to our graph, which is here. So we see that the corresponding x value is 2. So when x is equal to 2. So if we see that point right here, we notice that point is 2, negative 2. And that's our answer. Okay. Let's look at number 6. Number 6 says find the domain and range. So right here, we notice that this is a continuous function because we have dots that are connected with a line. So this is a continuous function. So remember, on continuous functions, we have to use the inequalities. So since we see an open dot right here, we know this is going to be less than. And since we see a closed dot here, this is going to be less than or equal to. So now we just need to see what our x and y values are going to be. So let's look at our points. Let's look at x's first. Okay. So domain is x. So if we look at the x's, notice that this dot that's open goes as far as -8. And this dot that's closed goes as far as +2. So that means our graph is enclosed in our boundaries of -8 and +2. So when we're writing our domain, we know -8 is our smallest value and 2 is our biggest value. So since that -8 is part of that open dot right here, we said that that open dot is a less than symbol. And since this closed dot here on the 2 is going to be part of the less than or equal to symbol, that's going to go here. And since we're dealing with domain, we know domain is x. So that is our domain, -8 less than x, less than or equal to 2. Okay, let's do the same thing, but now with range. Okay, so if I look at this closed dot, I notice on the y's, as far as it goes is +2, right here. If I look at the open dot, as high as it goes is +9. So that means my graph is, okay, so let's look at the range. So we're going to see how far down and how far up our graph goes. So if I look at our graph, I notice that it goes all the way down to -4, and it goes all the way up to +9. So if we look at our restrictions, our pink lines that I just drew, we notice that our graph is enclosed inside of my pink lines, which is my range. So I'm going to write my smallest value, which is -4, and my biggest value, which is 9. So my -4 is right here at the tip of my graph. So since we don't see any open or closed dots, and this is a solid line, we assume that this part right here is closed. So it's going to be less than or equal to. And then our y value all the way at the top, where that 9 is crossing through our open dot. And that open dot we know is the less than symbol. And since we know range is y, that's what goes in the center. Okay. So number 7 says find the domain and range. Since our graph is a bunch of points, remember this is called a discrete graph. And on a discrete graph, we just list the domain and range. So what I'm going to do first is I'm going to list all these points. So I'm going to say this is A, B, C, D, and E. So point A looks like it's -8, 3. So -8, 3. Point B is -5, 7. Point C is -2, 2. Point D is 1, -5. And point E is 7, -2. So remember, our domain is all our x values. So our domain is going to be -8, -5, -2, 1, and 7. And our range is all the y values. So it's going to be 3, 7, 2, -5, -2. Okay, almost done. Number 8 says write the equation for the linear function represented by the following table. So remember, when we have a table, the first thing we need to check for is if we see a y-intercept. Remember, we know we have a y-intercept when we see that x is 0. So right here, I see that x is 0, so that means our y-intercept is 9. So this is our y-intercept. Remember, our y-intercept is the same as the letter b. Okay? So now we need to find the slope. And remember, to find slope, we use the slope formula. So m equals y2 minus y1 over x2 minus x1. Remember, we can pick any points we want to be our y and x values. So I'm going to go ahead and pick these points. So x1, x2, y1, y2. So then I'm going to plug them in. y2 is 3 minus y1, which is 9. x2 is 2 minus x1, which is 0. So 3 minus 9 is negative 6, and 2 minus 0 is 2. So if we simplify this, negative 6 divided by 2 is negative 3. So we have m equal to negative 3. And so if we were to write this in an equation, y equals mx plus b, we have our b value, and we have our m value, so now we just write it. Y equals m, which is negative 3, x plus 9, which is our b value. So this is our answer. Okay, number 9. Number 9 says write the equation for the linear function represented by the following table. So remember, our first thing to check is to see if we have a y-intercept. And we know we have a y-intercept when x is 0. So let's look through our x's. So we have a negative 5, a negative 3, a negative 1, a 1. None of them are 0, meaning we do not have a y-intercept that's visible in this table. So what we need to do first is use the slope formula and find the slope. Okay, so we have m is equal to y2 minus y1, and then x2 minus x1. I'm going to go ahead and pick these ones. Let's see, x1, x2, y1, y2. So we have y2 to be 13 minus y1, which is 10. And then x2, which is negative 1, minus x1, which is negative 3. So if I was to simplify this, 13 minus 10 is 3. And negative 1 minus a negative 3, this minus a negative turns into plus a positive. So this is the same as saying negative 1 plus 3, which is 2. So this is our slope. Okay. Remember, if we're not given a y-intercept, we need to use the equation y equals mx plus b, and we need to find an x and y value on this table. So I'm going to just use these bottom ones, x and y. So that means instead of y, I'm going to put 16 equals 3 over 2 because that's our slope, and x, we said, is 1 plus b. So now what you can do on your calculator is type in this equation here, but use nsolve. So remember, nsolve is menu 3, 1. And so on your calculator, it would look like this. Nsolve, parentheses, 16 equals 3 over 2, parentheses, 1 plus b, comma b. And then you would hit enter. And then you would get, I believe, a fraction. Let me do that math real quick. you would get 14.5. So you'd get b equals 14.5. So that means our equation, our answer, is going to be y equals, I'm running out of room here. I'm going to go ahead and erase this part. So it should be y equals mx plus b. We know that our m is 3 over 2, and we know that b is 14.5. So that's our answer. Y equals 3 over 2x plus 14.5. Last problem, number 10, says write the equation for the linear function represented by the following graph. So when we see a graph, we need two things. So this graph is using y equals mx plus b. Remember that m is our slope, which we find using rise over run. And b is our y-intercept, which we find at where it crosses the y-axis. So crosses y-axis. Okay. So our y-intercept is right here at positive 1. It's where it crosses the y-axis. So that's our b value. And then to find our slope, we need to find 2 points that are on perfect corners. So I think I see a point right here. That's a perfect corner. And then right here, that's a perfect corner. So if I'm using these 2 points, I'm first going to do rise over run. So how far up do I need to go? So I need to go 1, 2, 3. So I'm going 3 up. And then how far to the right do I need to go? 1. So that means my slope is 3 over 1. And my y-intercept is 1. So if I was writing my equation, it would be y equals 3, because that's my slope, and then x plus 1, because that's my y-intercept. So that's my answer. Y equals 3x plus 1.